This is a video lesson for this week on circular arrangements. I'm trying to come up with a few lessons, little lectures, problems that we can do that will help you when you go to do the test, and just to make sure that you're catching all of the little, smaller elements of this unit so that you're prepared. So I want to start today with the first one, which is about arranging things when you're sitting in a circle, right? So typically, a common kind of question for this would be, how many ways are there to arrange a group of X number of people around a table? So I just want to kind of go through this and show how it's a bit different from the other type of question, which I kind of have over here, where you have them in a straight line. And you can see, let's start with the simplest case we can of just two people, just A and B. Now, in a straight line, you can have AB and you can have BA, right? These are two different arrangements of those people. But when you're looking at a circular table, if assuming the positions of the table are unimportant, which is typically a caveat of these questions, is that it's more a question of who you're sitting beside rather than where at the table you're sitting. So here you could see A sits across from B, and if we were to switch their positions, A is still sitting across from B, and this is not considered to be a different arrangement because A is still sitting beside the same person and still sitting across from the same person. So this is, this phrase on the question you'll see is, the seats are considered equivalent. And what that means is that, basically wherever A is, if A is, down here in position 1 or up here in position 2, it doesn't make a difference. It doesn't make it a different arrangement unless they are sitting beside or across from different people. So of course in a two-person situation, we can see here that with a straight line, you have two different arrangements, and in a circular one, you only have one arrangement, which is A sits across from B. Doesn't matter who's on what side of the table. So what we, of course, with two people, this is not really the kind of question that you're going to get. So let's try and we'll add a third person here. And we have A, B, and C all sitting at the table. Now, if we were arranging these in a straight line, we have 6 different ways of arranging A, B, and C. And we know that that 6, if we know our patterns here, we know that that 6 really comes from 6 factorial, or sorry, 6 factorial, 3 factorial, which is equal to 6. And that is how we know how many ways there are to arrange those 3 people. When we did only 2 people, there were only 2 arrangements, and that is equal to 2 factorial, which is 2. So we notice, how do I arrange people in a straight line is I just use the factorial. But how do you actually do this in a circle? So we only had AB when we arranged it in a circle. Now here, right, we're looking at 3 people. And what I'm going to do is basically in these questions, you always consider A to be stationary. So that would be your first sort of thing. So consider one element to be stationary. And we're going to do that because all the seats are considered equivalent. In other words, if I make all the arrangements possible with A here at the bottom, and then I shift A over here and make all the arrangements possible, I have not made any new arrangements because all the seats are considered equivalent. So let's put A back, and you can see that there are only 2 ways of arranging this table. There is B sitting on A's right, which as you see in this scenario with C on the left, or you could switch the positions of these two, and now B is on the left and C is on the right. Now, sometimes this is considered a different arrangement, sometimes it's not. So the other piece of information we need to know is whether clockwise or anti-clockwise arrangements are unique. So we'll just write this down. I believe in the question on the test, the anti-clockwise arrangements are unique, so that if A is sitting beside B and C, it matters who's on which side. So here B is on the left, C is on the right. If we move it back, C is on the left, B is on the right. This is considered a different arrangement if clockwise and anti-clockwise arrangements are unique. If they're not unique, then it doesn't matter that A is who's on the left and on the right. It just matters who A is sitting beside. A is sitting beside C and B. There's only one option. So we kind of need to break this down even further. So clockwise, anti-clockwise, unique. If it is, yes, then we have two arrangements. If it's not, we only have one arrangement. And again, here it's like B is left or B is right. And for this one, we just say A sits beside B and C. It doesn't matter who's on the left and who's on the right. Just move this over a bit. Okay, so we kind of have a bit of complication here, right? You could see right away there's two things that make circular questions a bit more difficult. Is that number one, we're going to fix one element so that it never moves because all the positions are said to be equivalent. Number two, it depends on whether sitting to the right or sitting to the left matters, or if just sitting beside is all that matters. Now, okay, so we've done it with 3. Let's add another person. So there we've added person D. And let's go through now all the possibilities. If this was a straight line, no need to list them all. We'll just say that we would have 4 factorial options, which we would have 24 options. Now, let's run through all the options here, again, keeping A stationary. And let's consider the clockwise and anti-clockwise arrangements to be unique. So let's list through all the possibilities. So with yes, we have A across from D, and then we have B left, C right. That would be one possibility. A across from D, B right, C left. Actually, let's keep it all in order. C left, B right. Okay, so we have these two options. And again, just to look at the diagram for a second, A is across from D. Here, B is on A's left-hand side. Sorry, now we have it properly. Okay, A is across from D. B is on the left-hand side. C is on the right-hand side. That's one arrangement. Now let's move C over and move B over. And now we have a different arrangement. D is across from A, like it says here. C is on the left. B is on the right. Okay? Now you can see that this is going to repeat 3 different times. Let's stick B across from A this time. And you can see we'll have the same 2 options as before. So we'll have A across from B. C is left, D is right. A across from B. D left, C right. Okay, so we added 2 more there. If we stick B as the person across the table, and the last option, of course, is we put C across the table. And you can see with C across the table, once again, there's only 2 different ways this can go: B left, D right, or we switch D over and bring B back, and now we have D left and B right. So let's add those ones as well. So A across from C. B left, D right, or A across from C, D left, C right. Those would be all 6 possibilities. Now, if we've been paying attention, if you've been thinking about the patterns here, what you notice about this big list of things that I've made is, let's simplify. Instead of saying across, left, right, all this stuff, let's just write the letters down. And you see it's DBC, then DCB, then BCD, BDC, CB, D, and CD. Sorry, there's a mistake in that last one. It should say CDB. Okay, sorry. Okay, now, in other words, right, if you look at these, right, let's consider this for a second, compare these two. There's 6 arrangements, right? Because A is stationary, and the other 3 are permuted through the 3 remaining seats. And because the orientation matters, each one of these is considered to be a unique orientation. So what we have here at the end is we have 6 factorial, sorry, I did the same thing, 3 factorial, which is 6, right? So when you're doing a circular arrangement, if the, we can now see the pattern, right? Instead of 2 factorial, we only had 1. Instead of 3 factorial, we only had 2 arrangements. Instead of 4 factorial, we only had 3 factorial arrangements. So what we know now is that if the clockwise and anti-clockwise orientations are unique, then the number of orientations equals n minus 1 factorial. So basically what we do, we consider this, sorry, I'm just going to say if yes, then the number of orientations is equal to n minus 1. So basically with a circle question, you need to ask 2 questions. You need to say, are the seats considered to be equivalent? If the seats are not considered to be equivalent, then it's just like organizing people in a line. You just take the number of seats and do that many factorial. Usually, though, the seats are considered equivalent, so it's more a question of who people are sitting beside rather than what particular seat at the table they've taken. The next question you have to ask is, do the orientations matter? Are they unique? So such that if A is sitting beside D and B, does it matter that D is on the left and B is on the right, or is it just the fact that A is sitting beside B and D? I believe on the test question, they are considered unique, so you would use this formula. If you come across a question where they're not unique, if no, then what we're going to do is we're going to further divide our answer, so we're going to go number of orientations equals n minus 1 factorial, because it's still all the same thing, but we're going to divide it all by 2, because if you consider this, right, A is across from C, or sorry, let me put this another way. If you think about the 2 people sitting beside A, right, if D is on the left, B is on the right, if that's different from the other 2, from them being swapped, right, B on the left and D on the right, then we keep both. If it's not different, then we just divide by 2 to basically cancel all of those extra ones out. So here's your sort of flow chart for dealing with these questions, and hopefully you can take on. I'll put a test question underneath this one as a practice, and hopefully you guys can do that one there to practice and make sure you understand circular arrangements.